Okay, so this is a quick walkthrough on how to do stereoscopic rendering in SunBurn in about 5 lines of code using the Stereoscopic Renderer plugin. So for this, we're going to go ahead and we're going to start off and we're just going to simply install the plugin. So that's all you have to do. Both the plugin and the source are distributed. So we'll say we want to go ahead and accept and install, and the installed plugin is ready to use. We already have the project open that we want to use it with, so we don't need to open up a SunBurn project. But the source is also distributed, so you can certainly play around with that, and it should be able to work for Windows Phone, and Xbox as well. So here I have the Dojo Indie project, pretty straightforward. And what I'm going to want to do is I'm going to want to add support for the plugin. So now that I've installed the plugin, I'll go to Tools and pick the SunBurn Plugin Manager, and I will select Stereoscopic Renderer. So wait for that to go ahead and pull that in. And I'm going to select that I want to make this green and activate it for the Dojo Indie. We don't need it for Content Indie since that's just a content project. So we'll hit Apply, we'll reload the project, and we will be good to go here. So basically, all we really need to do is, there's 5 lines of code that we need to add. First things first, we'll want to add a using statement here. And so we'll want to say using advanced rendering. And so advanced rendering is what gives you the stereoscopic capabilities, and in particular lets you convert to using a stereoscopic renderer that encapsulates all SunBurn renderer in a stereoscopic mode. So in order to use a stereoscopic renderer, you need to create an instance, a variable for the stereoscopic renderer. So you just say stereoscopic renderer, and we'll call this stereo renderer. And then this will be the renderer that we'll use, and there's basically 3 main things that we need to do. We need to construct it, we need to set its view matrix, and we need to give it parameters so that it can render for the projection. So we'll take this, and the first thing that we have to do is at the end of load content, we need to create the stereo renderer. And the reason for this is because there's a few different things that we need in order to ensure that this works correctly. Like we need the scene interface to have content, we need the environment to be created, and you'll see this in the constructor itself. So let's go ahead and create our stereo renderer. So stereo renderer equals new stereo renderer. And so here's all the different parameters. So the first few are just ones that will be standard in every SunBurn project. So you'll want to pass it the XNA game. You'll also want to pass it the current scene interface. And I've picked names that should match to the SunBurn defaults. So we'll pass it the environment, we'll also pass it the scene state, and the frame buffers. Now we also have this. Now we have some specific items that are associated to stereoscopic rendering. So FOV does affect stereoscopic rendering just a little bit. This is FOV in radians. So what we'll do is we'll say math helper dot 2 radians, and the standard for SunBurn is 70, but whatever is appropriate for your project. The near plane in this instance, a lot of SunBurn projects are 0.1. And then the far plane, SunBurn typically uses environment visible distance. So this kind of sets up the viewing frustum that we'll be rendering. And then the last 3 are 100% new and are about stereoscopic rendering. So the first is stereofocal length. This value is basically where stereo convergence is relative to the camera in distance. So if you set this at, let's say, 6 units out, that means that anything in front of 6 units is going to look like it's coming out of the screen. Anything at 6 units is going to be basically at screen depth, and then anything further than 6 units from the camera will appear to be inside the screen. So in this case, we'll set that to 6, because that's an interesting number. You don't want to set that too far, because pop-out 3D is not incredibly comfortable to look at. And then depth effect, this shows how much the depth effect you get. So 0 is no depth, 1 is maximum depth. This is similar to the 3ds slider for maximum or minimum 3D effect. So we'll just start off kind of in the middle, say 0.5, And then the final is render mode. So stereoscopic render mode has a few different render modes. So you can set it to no stereo. So this is configurable. Once you pick stereoscopic, you don't always have to stay stereoscopic, and you'll pay basically no performance penalty for this. There's anaglyphic red cyan optimized for color balancing, side-by-side full color for 3D TVs and monitors, and top and bottom full color for TVs and monitors. So for this example, we're going to pick anaglyph red cyan optimized. So now we've constructed it, and I believe that the correct thing to do there is this. And now we've got to add our 3 other lines of code. So in the update method, so we'll jump to the update method. So right after the view is created, so you can see that the view is created, we need to set this view information on the stereoscopic renderer. So we'll say stereos renderer, and what we need to do is we need to update the camera stereo, and we will be passing it in the view matrix. If you are using your own camera information, you can see there's another overload here where you can actually specify the camera position information. But in this case, all we need is the view. So we'll just pass this the view because this is the SunBurn default view. So now we've set the view information for the stereo renderer. And now the final thing we need to do is simply call render stereo where we would normally draw. So these are pretty familiar to anybody that's used SunBurn. This is about beginning frame rendering, this is about rendering the frame, and this is about ending the frame rendering. In this case, you can actually comment all of these out, and you can simply say stereo renderer dot render stereo, and we'll pass it the game time. And for this example, this is all that we need to do. Now this should just run equivalently. So we'll save this, and let's fire this off. Now before we run this, I do want to call out one thing, is that there's a configurable mode that it's very valuable to set when you're first working with this. And that is stereo renderer dot enable depth tuning mode. And enable depth tuning mode gives you the ability to control the stereo focal length as well as the depth value using RNF and T and G. And that's documented in the documentation. So let's go ahead and set that because what we'll want to do is we'll want to see the effect of playing with those different numbers. So first I'm going to change the depth mode. So I pressed F and we're down to 0. You'll also notice that color it kind of gets a little bit blue in the optimized mode. That's because anaglyphic tends to have what's called retinal rivalry with certain color palettes. So although this might look a little bit weird to your naked eyes, this actually looks really good using the traditional kind of red cyan goggles. And so you can see using just the default of 6 for the stereo focal length, this is kind of the maximum amount of 3D we get, and then you can see that we go to the minimum amount of 3D here. So now what we can also do is change the stereo focal length, and what you'll observe is that as we change the stereo focal length, it kind of sort of looks like the same thing is happening. But in this case, the stereo focal length, you'll see that the red, if you focus just on this candle holder here, the red is on the right, and then as I change the stereo focal length, the red actually moves to the left. And what that's doing is that's now actually pulling that so that that looks like it's popping out of the screen because the stereo focal length is now behind the candle holder. So again, you kind of pull it in, now it looks like it's in the screen, now it looks like it's out of the screen. And so you can change these values however you want. You can also look down here in the output window that's kind of in the lower left of the screen there, and you can see what the depth effect and the stereo focal length settings are. And the stereo focal length is a function of your environment visible distance, so it doesn't matter where you're at, it'll let you scale that at a dynamic value that just makes sense for whatever you have. And you can see as I get closer to this, the stereo changes as a function of the stereo depth effect. So hopefully you've found how easy it is to use a stereoscopic renderer in literally less than 5 lines of code. This is fully documented and should really help you get stereoscopic rendering almost instantly in any of your SunBurn games. The last thing I wanted to actually talk about is holophone, and how I've implemented some of this 3D functionality in my phone game. So here you can see this is the phone emulator. And holophone, although it looks kind of a little bit strange on the flat screen, has some really cool rendering tricks that it plays with when you're actually moving the phone in space. So you get a kind of a very cool holographic effect with the phone, and combining that with stereoscopic 3D is in fact super duper compelling. So I wanted to show you what something stereoscopic might look like in terms of utilization for that. So what I did is I added this little 3D button up here. And it toggles the 3D panel in, which gives users some interesting information. It tells you this is depth 3D setting, and then this is what is the 3D effect. So I've actually just mapped more or less those parameters to this. So here you can see as I change the depth effect, I'm moving how far apart the separation is of the virtual cameras. So you get a really nice 3D depth effect here. And then much like previously, you see that the red is over here. When I switch to pop out mode, this actually looks like it's popping out. And you can see that the lines, the color of the lines here have actually changed. So in this case, if you're wearing the goggles, you'll actually see that the car looks like it's coming out towards you, whereas in the other case, it actually looked like it was going in. And you can see that the focal length is set to almost the back of this box. And the reason why you can tell that is because these boxes don't actually get ghosted at all. And wherever the stereo focal length plane is in space doesn't really have any stereo effect. And again, if I were to switch this back to deep mode, these guys would have a big amount of parallax effect in their stereo. So anyway, this is just an application, again, kind of demonstrating that it works just fine on Windows Phone, as well as Windows and Xbox. And here's how you can use these different techniques to have cool effects in your games.